From the electrical control library, we drag and drop a push button onto our diagram. This will serve as the start button for our control panel. Using the CAD tools provided, we can add more detail to our control panel. Note the variables associated with the solenoids, RET for retract and EXT for extend, and the sensors in and out for both setup A and B. To design our SFC, we simply need to open a new diagram. Instead of a library, all the tools that are needed to build our SFC are found in this toolbar. First, we select the initial step. Next, we take out a transition step. Choosing guided mode provides the user with a list consisting of all the variables from our pneumatic system. Simply select Start and the correct syntax form for the push button is provided. A comment can be added if we wish to include additional information about this step. The next step that is selected is a standard step, which corresponds to the extension of cylinder A. Following that is a transition step associated with sensor A out. By duplicating the first standard step, we can create a second step that is automatically incremented from step 2 to step 3. The condition for this step will be to retract cylinder A. Notice that when the syntax is changed manually, the font color changes since the variable is not recognized. Once corrected to a known variable, the font color is restored. This tool is very useful since any syntax errors that occur can be detected and corrected immediately. The remainder of our SFC is built by duplicating components that are already on the diagram. In guided mode, quick keys are provided to help the user with logic and mathematical statements. Here, we are assigning the transition step to sensors A in and B in. We can also include a timer step. In guided mode, timer statements are also provided with the correct syntax format. We simply need to define the step number n and the time A in milliseconds. To link steps, simply click from one connection port to the next. And branches are automatically created and can be moved horizontally or vertically. To complete our SFC, the last connection is made between transition 7 and the initial step 1. The link is automatically converted to a jump, but can be converted back to a link if the user wishes. Our SFC is complete and we are ready to simulate. We tile the windows vertically so that we can see both diagrams at the same time. Press on the simulation button and observe that the active step, which is currently the initial step, is highlighted in red. To begin, click on the Start button. Watch as the SFC proceeds from the initial step to the next step once the transition is triggered and fired. Note that the active step or steps are always in red. Since cylinder A retracts faster than cylinder B, the timer will not activate until both A in and B in have been activated. The timer counts to 2 seconds and then the SFC returns to step 1.